Hello everyone, welcome to my YouTube channel Know About Embedded System. In today's video, we will develop an embedded C program for ADC for STM32 microcontroller. So using STM32 microcontroller, we will develop a program for ADC. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel, click on bell icon and share this videos to your friends and colleagues. Let us start the video. ADC programming using STM32 microcontroller. So guys, in the previous videos, we have already discussed how to develop a programming for timers, how to develop a programming for GPIO, and so on. Many things we have discussed. So today we will concentrate on ADC, but before entering into the actual video, actual content, so we will understand how many ADC channels are available and what type of ADC available in STM32. So in STM32 microcontroller, so we have SAR ADC, and this SAR ADC of 16 channels. You can see here this point. So there are totally 16 channels are available, and along with that there is a built-in temperature sensor. You can see this part in ADC. In this ADC module or in this microcontroller, there is a built-in temperature sensor is also available. So we are going to develop a program to read the temperature data from the microcontroller. Okay, so now let us continue here. So in this STM32 controller, so we have 12-bit ADC, as I told you already. So we are going to use a 12-bit successive approximation ADC, or SAR ADC we will use. Next point, if you observe here, there are totally 19 analog inputs you can give. 19 analog channels are defined. Out of that, 16 analog channels can be given from externally, but the 3 analog channels are built into the microcontroller. Those includes your built-in temperature sensor and built-in voltage, input voltage, and so on like that. Okay. Next, the ADC can be configured in a single conversion mode or continuous conversion mode. You can configure in a single conversion and continuous so what is this? So you can watch, I have one more video, you can watch that as well. In that video I have explained what is ADC, how ADC works, all those things I have explained in detail. Please watch that video. I'll share the link in the description box. So now coming back to the point here, in STM32 microcontroller, ADC is capable of handling, or ADC can convert in ADC can operate in 12-bit, 10-bit, 8-bit and 6-bit configuration. How much configuration or how much resolution you want? So according to your resolution requirement, you can configure ADC in 10-bit, 12-bit and 8, and so on like that. And also you can generate interrupt upon end of conversion. Okay, so this much is the theory part, simple theory. Now we will move to the register part. What are the different registers we're going to use? So we are going to use, first one is APB RCC APB2 ENR. This register APB2 ENR is used to enable the clock. Then we have control register, ADC control register. Then we have ADC status register. Then we have ADC sequence register. Then we have ADC data register. So like this, 5 to 6 major important registers we have to use in order to configure your ADC and to read the analog data or digital data from the sensor. So in the coding, so I have already created some of the macros here. You can see this is for ADC clock enable, this is for ADC on, this is for start of conversion, and this is for end of conversion. So I have already defined some of the macros for end of conversion, start of conversion, ADC on, then clock enable. Okay, now let us see one by one. So this statement, whatever you're saying, this is going to enable the clock. So enable clock to port A. So line number 26 is going to enable the clock to the port A. Next, I'm going to enable the clock to the okay, so I'm going to enable the clock to the ADC. So ADC clock is defined under APB2 ANR. The clock is enabled. Next, I need to enable the temperature sensor value. So in order to do that, so we have a separate ADC1 underscore. So this is a register CCR. Okay, here. So this macro, whatever you're seeing, ADC underscore CCR TSV reference. That means this macro, whatever you're seeing here, this macro or this statement is going to enable the temperature sensor, which is available inside the microcontroller. Okay, this is a very important thing. So this is a macro which is already defined in the header file. Okay, so that's one thing you should know. Next, I need to enable the channel. In order to enable the channel, just I need to mention ADC SQR3 is equal to 16. So I'm going to use temperature sensor which is connected to the 16 channel. That's why the SQR is a sequence register. So here I need to mention which channel I'm going to use. I'm going to use channel number 16. Okay. Then I need to enable the ADC. If you want to enable the ADC, I need to use a register called a CR2. ADC CR2 is equal to, so I have already defined a macro here that you can just use it. So first major steps are done now. So we have enabled the clock for port A, enabled the clock for ADC, and enabled the built-in temperature sensor inside the microcontroller. Then enabled the channel number, and then we have enabled the ADC now. So now I need to give the start of conversion. So if you want to give the start of conversion, so we have to, so start of conversion, you can see this is my bit number 30. Okay, so just you can use that. Copy this, and then ADC1 start of conversion, SOC stands for start of conversion here. Now, so now we are done. We have enabled the start of conversion. Sorry, there is a small mistake. Now we have enabled the start of condition. Now I have to check end of conversion bit. So once if you enable the start of conversion, you have to wait for end of conversion. So so that we have to do it in a polling method. So while I'm going to use a register called as SR here, and with end of conversion, you can see this is my end of conversion UOC. Okay, now so if the end of conversion is not set, then it will wait here only. So this is an infinite loop, or you can say polling statement. Using this polling statement, we're going to wait here until the conversion completes. Once the conversion is completed, it will break the loop and it will come back. And after that, so I'm going to read digital value here. Digital value is equal to, I need to use ADC1DR. Okay. After that, so this part, whatever you're saying, so this part, whatever you're saying, this part is used to convert your raw digital data to equivalent temperature sensor. There is a small calculation. So your temperature temperature in degree centigrade is equal to digital value into 3.3 divided by 4095, and then so actual temperature is equal to this Vsense value minus 0.76 divided by 2.5 plus 25. This is a standard equation for a temperature sensor which is available inside the microcontroller. Okay, so that's why I am not explaining this part in detail. So now we are done with the coding. Now let us compile it. We will check for the error. Okay, no errors. Build it once again. So now we'll go for debug. Okay guys, this is called debug window here, and here I kept it 3 variables. You can see these are all the 3 variables, nothing but digital value, temperature, and sensor value. So like these 3 variables I have kept it. Now let us run the code here. What will happen? Now you can see. So this is actually the digital value, actual digital value after converting analog to digital from the temperature sensor. The temperature, whatever you are seeing, this is actual temperature which is changing, and this is your sensor value, the variable what I have used. Okay, so just observe what is happening there. Temperature, you observe temperature is changing to 25.45, something like that, right? So this is how you can use your ADC, and you can develop a program for ADC, and you can read analog data and convert into digital, and then you can do the calculation, and according to your requirement you can do the programming, and you can produce your own output and logic. So I hope this video is an informative video. If you feel this video is an informative video, please click on like button, share this video with your friends and colleagues, and subscribe to my YouTube channel and click on the bell icon.